Okay, Assalamualaikum. Let's continue with chapter 2. Chapter 2 is Introduction to Logic. So, in this chapter, we're going to learn on logic, propositional logic, formal proof using truth table, bitwise operation, quantifiers, and predicate calculus. Okay, so the definition: a formal language for representing knowledge and for making logical inferences. So it helps us to understand how to construct a valid argument. So this one is a definition for the logic. So what is a truth value? So truth value is any sentence or statement which can be either true or false, but cannot be both. So either true or false only. So that sentence can be assigned. If true, we can assign T or 1. If false, we can assign F or 0. Okay, so look at here. Put here, what is logic? So logic is the principles of values. So we're going to use rules to operate on a statement or several statements. So statements can be one statement or many statements to reach a correct solution. Okay, so the truth value, any sentence or statement can be either true or false. So this true or false we can state as T or 1 or false F or 0. Okay, for example, if we say that the world is flat, so it's definitely wrong, isn't it? It's definitely false. So for the truth value, we just put F here. Okay. If 2 plus 2 equal to 4, so meaning that this statement is true. So just put T. Or you can put false as 0 or true as 1. If you don't want to use T, you can use 1. Okay, 3 is positive integer. So correct, isn't it? So just put T. Or you don't want to put T, just put 1. Okay, let's say the statement is like this: all doctors are rich. So this one we cannot say either false or true. So we can call this statement or these propositions are meaningless or ambiguous propositions. Or big house is good. So we can say, okay, is it true that the big house is good? No, we can't say that this is true or false. So this one is meaningless proposition. Alright. Okay, next. So propositional calculus, we can represent statement to express relationship between them. Okay, so for a proposition, we can use lowercase. Okay, so for position, we can use any values, any word, P, Q, R, S. If you want to use A, B, C, D, OK, X, Y, and Z, also can. So these P, Q, R, S, we can combine them. Combine P, Q, R, S. For what to combine them? To obtain compound positions. Okay, so when we combine them, we can use connective symbols. So what are the connective symbols? Okay, the first of all, you need to understand that P, Q, R, S, we can combine them. So we can combine them to obtain compound positions. So how to combine them? Using connective symbols. So what are the connective symbols? So this is the connective symbols. Okay, connective symbol can be not. This one is the symbol for not or negation. Okay, this one. And like this. Or this one is, we call it as if then, or we can call it implies, conditional, implies, the other name is implies or conditional, or in other words we can say it as if then. Okay, so one more thing is the last one is biconditional. So biconditional is if and only if and only if. Okay, so these compound positions can be present in truth table. So this one, okay, this one we call it as truth value. So for FTT011 is a truth value. So what is a truth table? So truth table, okay, displays the relationship between the truth values or propositions. Okay, truth value and truth table are different. So truth value is we can represent TF01, but for the truth table, we can represent the relationship between the truth values or proposition.